Good afternoon, everyone. Let me start by thanking the organization for accepting my talk at this great event. And let me also thank you all for being here and allowing me to share some knowledge about GitOps. So without further ado, we'll delve right into the talk itself and talk about GitOps. So what do we have for today? So today, we're going to have a brief overview of what GitOps is. So the idea is for us to have a broad understanding of what GitOps is, some of the things that it can do for us. We'll also see a little bit of some of examples of some GitOps CD software agents. So the idea for this talk is a little bit based on Kubernetes and on Kubernetes software delivery pipelines. So we'll see some examples of agents that can use the GitOps mindset to deliver software. We're going to see an example of such a software agent, and if we have some time, we'll see a few extras that usually come in as questions. So let's start with a story. So it's a beautiful day. So spring has come. Everything is looking good. And I decided I want to do a change. It's a tricky change, and I'm being a little bit over dramatic here, but the idea is that there can be some catastrophe that can happen. So my colleague Joe has a good sport, and because of our internal processes required it, he decides to take a look. So I submit a PR, he takes a look, everything looks okay, we have a few tests, everything looks good. So we're good to go. We decide to go ahead. Long story short, we have a failure. For this specific case, a Kubernetes cluster is gone. So basically, this is us at this point. So everything is gone. There's a huge failure, and we need to tackle this. So there's the second part of our story, of course. Because we have everything in infrastructure as code, we can just relaunch the cluster, right? So that's fine. Now we need to figure out what needs to be launched. So we have infrastructure as code, we launch infrastructure, but now we need to figure out what apps were there, what configuration files needed to be there, what sort of pipelines need to run. So because we have pipelines for everything, we just activate those pipelines, right? So after a while, we go on and figure out what needs to be run, what was running on that cluster, we figure out everything. But a few things don't go as exactly as we planned. So we discovered that one pipeline was deactivated, but we don't know why, because the application was running. We need to go to the team and figure out why. Also, we saw that one pipeline ran successfully, but the application is not working. Do we know why? Maybe a team had some kind of manual change. There was some kind of process that wasn't documented. So our headache still continues. So right. So maybe we could find a better way to actually deal with this. So this is where GitOps comes in. So GitOps is based on a few principles, and we're going to state here 4 and see what we mean by this principle. So the first is that the entire system should be described declarative. What does this mean? So Kubernetes is just one example of many tools that are declarative and can be treated as code. What this means is that the configuration is guaranteed by a set of facts and instead of a set of instructions. So, for example, a set of instructions would be deploy this server, put this file at this location, restart this service. And basically, the idea is that we just state facts. We say that I want one server with an app running that reads this configuration file, and then something. Some kind of agent knows how to interpret that kind of DSL and actually knows what to do. Our applications will, of course, be versioned in Git, and Git will be our only source of truth. All of our apps can be easily deployed and rolled back to and from a Kubernetes cluster, and even more importantly, like we've seen in the example before, when disaster strikes, our entire cluster infrastructure can be quickly reproduced. Also, the canonical desired state is versioned in Git. So with this declaration of our system stored in a version control system and serving as our canonical source of truth, we have a single place from where everything is derived and driven. This, of course, makes rollbacks trivial. We can use common Git operations like rollback to do a rollback. And we, of course, we have Git security guarantees where you can use SSH keys to sign commits and enforce strong security guarantees. Of course, here the example is it's with Git, but we can extrapolate to any kind of version control system that so that we can actually perform the same kind of principles. Also, approved changes can be automatically applied to the system. What this means is that once we have all of our state kept in Git, the next step is, of course, to allow those changes to be applied automatically to a system. This is significant because we don't need some kind of cluster credentials to make a change to a system. So with GitOps, we can segregate environments in which the state definition lives outside of that environment. This, of course, allows us to separate what we do to how things are going to be done. And of course, last but not least, a very important component is that software agents need to ensure the correctness and also alert us on divergence. What this means is that once our systems are declared an inversion control system, a software agent can inform us of any kind of divergence from Git that is applied on a cluster. That agent can actually go the extra mile and basically do a self-healing process and actually put everything on the state that it's supposed to be. So what do those principles can actually do for us on a day-to-day basis? So we can gain a little bit of increased productivity. So with continuous deployment and automation and an integrated feedback loop, we can speed up mean time to deployment. Of course, this means increasing our overall development output by a few times. We also gain a little bit of enhanced developer experience because now we are not pushing code, and not containers. This means that us and developers and everyone on the engineering teams can use familiar tools like Git to manage Kubernetes without having to know the intricacies of everything that is underneath. So newly onboarded developers can get quickly up to speed and be productive in a few days instead of months. We also gain improved stability because now we are using Git flows to manage our clusters and automatically gain a convenient audit log of all the cluster changes outside of Kubernetes. An audit trail of who did what and when to our clusters can be used to meet compliance requirements like SOC 2 or PCI compliance. We also gain higher reliability because we now are using Git's capabilities to revert and rollback and fork repositories. We can gain stable and reproducible rollbacks. Our entire system is described in Git, and we gain a single source of truth from which we can recover from a meltdown, by that reducing our mean time to recovery. We also gain consistency and standardization because GitOps provides one model for making our infrastructure, apps, and Kubernetes add-on changes, we'll have consistent end-to-end workflows across the entire organization. We are not only using our continuous integration and continuous deployments pipelines. Everything is driven by pull requests, but our operation tasks are also fully reproducible through Git. We also gain, like we've seen before, stronger security guarantees. With Git strong correctness and security guarantees, backed by strong cryptography used to track and manage changes, as well as the ability to sign changes to prove authorship and origin is key to a secure definition of the desired cluster. And of course, with all of this, we gain easier compliance and auditing, and we can use tools like kubediff or teradiff or ansiblediff to actually compare the state in Git to actually what it is applied on a Kubernetes cluster, for example, and alert on divergence, and of course make those changes, make the necessary changes to actually reflect on a cluster. So now, with this in mind, we're going to touch briefly on a few software agents, mostly focused on Kubernetes software delivery pipelines. But before we go into that point, we're going to see what kind of requirements we have for such a software, for such agents. So first of all, it needs to be declarative. So like we've seen, we don't want to have a succession of imperative statements. We want a declaration. We want to say, I want X replicas of this application running, and it will going to read from this configuration file. We also want them to be automated, so we want agents that understand this kind of declaration and know what to do when they see a change. They need to be audible, so we have a state declaration in Git, but we also need for them to be audible so that we know what they are actually doing. For our specific use case, we want them to be designed for Kubernetes, so the idea is that they come with Kubernetes in mind, and so that they are cloud native. Of course, they need to have out-of-the-box integrations. We don't want to be reinventing the wheel and having to write everything from scratch. But at the same time, we want them extensible. So we all have some specific use cases that are very custom to our needs. So we actually need that those tools allow us to actually plug in some changes that we actually need for a specific workflow, for example. So let's start for a popular software agent, which is Flux. So Flux was developed by the company that coined the GitOps term, which is called Weaveworks. And the idea for Flux is to keep clusters in sync with the configuration in Git repositories. So the idea is that Flux understands a DSL, and then it will make sure that whatever is running in the cluster matches that definition that is in Git. So from a broader view, Flux will have a source controller that will actually look at definitions of what should be on a Kubernetes cluster, and then it will interact with the Kubernetes API to make those changes consistent. Of course, Flux also has support for Customize and Helm, which you are going to see in a little bit in the demo, and it can actually understand what a customization or a Helm shard is and actually make those changes to a cluster. Another popular software agent is also Argo. So Argo is a declarative GitOps continuous delivery for Kubernetes. So on a high level, it works in a very similar fashion to Flux. So it knows how to look to a definition on a Git repository and knows how to interact with the Kubernetes cluster. It also has support for Helm charts or customizations, has a very nice interface, has a few concepts other than that Flux doesn't have. So it's a very nice tool and I would recommend as a tool to explore. In the middle of the process that has been going on for the past few years, where the GitOps has been gaining traction, the Argo team and the Flux team realized that they were trying to solve the same problems. So one of the ideas that they came across was to actually build something that they are calling a GitOps engine, so that common tools or common operations, would be abstracted into that engine, and then each project will build their differentiator features on top of those. So that's also a public and open source project on GitOps, and I encourage you to look at it. And last but not least, we have Jenkins. So Jenkins has been having a bad rep for several years now, and many people say that Jenkins was not built with cloud native in mind, and Jenkins X it's an effort, a very good effort on that front. So it's the idea to evolve Jenkins with a GitOps mindset in mind. And the idea is to help teams collaborate and accelerate their software delivery at any scale. So at a high level, it also works in a very similar fashion. It knows how to look at a definition of state in a Git repository. It knows how to work with the Kubernetes API, has support for several integrations, so it tries to achieve the exact same goals as Argo and Flux. So how would a GitOps continuous delivery pipeline would work? So we will do a code change. That code change will eventually develop into building a container. That container will be pushed to a container registry, and then we could have one of two options. If we're really going with a GitOps option, something would actually register that a new version of the software was pushed to a container registry. It will do a git commit into a Git repository, and then a deployment operator that is looking at that Git configuration would would apply that change. If we want to short circuit this, we could have the deployment operator actually looking directly at the container registry and deploying the application. But then we will mostly lose track of the actual change. We'll have to assume that only the last change is applied. Of course, the deployment operator could be the one that is looking at the container registry and would function as the config updater. So we have those two options on the table. So now we're going to see a quick demo of Flux in action. So we're actually going to deploy an application. So we're going to launch a local Kubernetes cluster. We're going to deploy an application and by using Flux. So I have here a repository that I'm going to use. So here we go. So let me just start by demonstrating the repository itself. So the idea, so this repository will be made available. So we are going to deploy an application called pod.info. So I'm trying to use something from the community that you guys can always look back and see the application itself. And we're going to do a quick overview of what is here in the repository, so that we understand what is happening underneath the hood. So we're going to use customize to do the deploys. So Flux will use its customized controller to actually do a deploy. So if we go into this staging cluster, where we have a definition for a potential staging cluster, we see that we have a few files. So this the Flux system folder is something that Flux will use to store some of its some state, and I left it here just as an example that an operator can actually do a commit and add information to a Git repository. So we'll start by looking at this file, which is called web app source. So in this file, basically what we are saying, we are declaring a source, which is a Git repository, and we're basically pointing to the repository that I mentioned here, and we will be using this repository as a base for the customizations. So what do we have more? So we have something here called web app common. So let's take a look. So this web app common basically says that it's going to use that reference, that Git repository, and whatever customization, because this declares a customization, whatever the customization is, it lives in that repository under this folder. So let's take a look. So if we go into deploy web app common, so here we see that we have common Kubernetes resources. So we have a namespace, we have service accounts, and so on. Quickly, let's take a look at the other two files. So we have something called web app backend. So web app backend uses the same approach. So it's also a customization. It's going to use that Git repository. The files live under web app backend. And here we have a depends on dependency, which is quite interesting, because now we can say that whatever is going to be deployed by web app backend needs to be done after web app common, which makes sense because we want to deploy an application whenever a namespace is deployed. So let's just quickly take a look at what is there in backend. So here we see that we have our normal Kubernetes manifest, so a deployment, horizontal pod autoscaler, and a service. And the same thing very quickly with web app frontend, same thing. Git repository where the customizations are living, and it depends on the backend. So let's just boot this up. So I'm going to actually use this README as a reference. So I'm going to launch a cluster. So it's saying that already exists, so I can delete it, just so that we have something right from the start. I had one locally, so I'm creating one from scratch, just to be sure that we are not going over anything. So it's just booting up. I'm using K3D for this. It takes a few seconds, so we're good to go. So now we have context, kubectl get node, just to be sure that we have everything here. So we have a cluster, we have agents, we have the master, so we're good to go. So now what we're going to do, this part I have already done, so I'm just exporting some variable files so that my local cluster can actually connect this GitLab repository and do whatever it needs to be done. So let's start by bootstrapping what is Flux needs to do. So basically what I'm telling here is what repository it should connect to. This lives under a group, and what branch it needs to look at, and what the folder should look like. So here Flux is just booting up. It's starting up, and basically it's waiting for the controllers to actually start. So it's basically because we didn't say anything, so it's going to install the notification controller, the source controller, the customized controller, and the Helm controller. Once that's done, it will say that Bootstrap has finished, and now we can actually start to see what changes is it going to apply. So we're going to I mistakenly close that down. So here we go. So going to Flux GitOps. And now we can actually see it's the same file that it's in here. Never do demos live, right? So what we are going to see. So something that we're going to see here is that doing the customization. So here we can see that Flux is actually looking at the whatever is in Git and doing some applies. So it basically saw that it had something called web app common, and it has already applied. Did the same thing for web app backend. It has already applied, and it's still going with the web app front end. So we can actually see that happen. So basically here we can just see that if whatever is being launched. So now we can see that we have backend and front end, and last but not least, we can do a port forward and see if the application has been deployed, and we can go to our browser, and here we go. So we have an application. We can just ping it just to be sure that it's running. We can see that it has metrics, so we can actually be sure that this is the application that we are running. And just as a cleanup, we can we can clean up and everything going to its original state. So a few extras that usually come about in the question. So everyone, one of the first things that people usually ask is about secrets. So how do I manage secrets with this approach? So very quickly, there are a few projects to handle this. So two that work in a very similar way are Seal Secrets from Bitnami and SOPs by Mozilla. So the idea is that you have an agent that has access to a secret key inside the Kubernetes cluster, and you will encrypt your secrets with a public key, like public-private key encryption, and then when we deploy to a cluster, the agent inside the cluster with a private key can decrypt and create a secret. And of course, you have also options like the Vault Agent Sidecar Injector that can connect to a Vault installation and actually inject the secrets via environment variable, or to a file inside the the file system. And also another approach, another question that comes is a question between what's the difference between GitOps and infrastructure as code. So basically the idea is infrastructure as code only manages the infrastructure side of things. GitOps aims at being more, so the idea is that we manage everything via Git. Of course, here we saw examples of continuous delivery pipe agents for Kubernetes, but the idea is that we can extrapolate this and actually have a definition for all of our systems, being it infrastructure, configuration, Kubernetes apps, whatever you name it. Everything is in Git, and then we have software that actually looks at that definition and knows what to do. And another question that comes is when should I use push and where should I use pull? So the idea for pull instead of push, or for example, instead of having a pipeline doing a push of something that should go into a Kubernetes cluster, for example, is to have an agent that lives inside a cluster that actually pulls at the definition and knows what to do, is for enhanced security. So imagine that you are using, for example, a multi-cloud installation. You have clusters in Europe, you have clusters in Asia, you have clusters in North America, for example, and your pipelines run only on one region. So for you to do a deployment, you would have to open a cluster possibly on another cloud provider to those pipelines. If actually have an agent that runs inside those clusters, there's no need for that connection, and the cluster can actually pull that information and operate on its own. And that's it for my part. I'll leave several links in the next slide for reference. You can go and skim all of those, and we'll have links on those pages to actually go a little bit longer on this path. And thank you very much for giving me this opportunity. I hope all of you learned something today.